Did you wake up?
Yeah, I did. I don't know. I don't know if he's gonna stay woken up though. I can only try so hard. All right. So today we're going to be doing more about graphs. Previously, we talked about what it means to have a rate. We saw rates on a graph. Today, we're going to be talking about how rates and slopes relate. They're roughly the same thing. And then we're also going to be talking about that streamlined and efficient method for graphing that I keep telling you guys you're going to learn, but I haven't taught it to you yet. So today we're finally going to learn it. Right? Okay. So let's go ahead and do an example that has to do with rate and slope. And so I'll show you how these are roughly the same thing. So here we have two examples. One on the left is the price of a 2-year replacement in the cost of computers for some office building, and the one on the right is a 3-year replacement. They look fairly similar, but they have different slopes, right? They cost people a little bit, a slightly different amount of money. So first of all, let's calculate the slope on the 2-year replacement graph. Oops. So to calculate the slope on any graph, all I need to do is choose 2 points, and I need to find the difference in between rise and run on those 2 points. So I'm going to choose the point 2, 3, and then I'll choose the point, I don't know, maybe I'll choose this point way up here. It's important to note, it doesn't really matter which of these 2 points you choose. If you choose 2 different points, you're going to find the same slope after you do this. So remember, the slope of the graph is the rise over the run. Right? My rise is my y values, and my run is my x values. The 2 points that I chose were 2, 3, and 8, 2. Sorry, 8, 12. So to find out what the difference in the rise was, I just subtract my 2 y values. I find the difference between these 2 values. So I'm going to say 12 minus 3. That's what I have on top. To find the run, right, the horizontal distance I cover, I just need to find the difference in my x values. Okay, so I have 8 minus 2. All right, the difference in my rise, 12 minus 3, that gives me 9. 8 minus 2, that gives me 6. And then this simplifies into 3 halves. So that is the slope on my 2-year replacement graph, 3 halves. That's also the rate in cost to get computers. Basically, what this is saying is that if you have a slope of 3 halves, it's saying for every unit you move over, you get a rise in 3 halves value. Since this one's talking about thousands, for our 2-year graph, we're getting 3 halves of $1,000 per year to replace these computers. That means 1.5 thousand. All right, so now if we want to find the slope on the 3-year graph, we play the same game. For this one, I'm going to just choose the origin for this one because it does cross through the origin, and that's going to make things a lot easier. And maybe I'll choose this point way out here, 9, 12. So I have 0, 0, and 9, 12. Okay, so 0, 0, and 9, 12. All right, so once again, I find the difference in my vertical values, which is 12 minus 0 on top, and then I find the difference in my horizontal values. So on the bottom, I have 9 minus 0. All right, this is just equal to 12 over 9, which is equal to 4/3. Okay, so 4/3 is slightly more. Is it? No, 3 halves is a little bit more, I think. Yeah, so one of these is a little bit more expensive. Right? Okay, and so they've asked us to use the graph of the 2-year replacement program above to find the cost of computers per year. Okay, so like we were saying earlier, it costs this much in thousands per year. Okay, so we just convert that into a decimal. 3/2 isn't 1.5, is it? Yeah, it is. 1.5 thousand dollars per 1 year.
How can you figure out which number to deduct from the other number as far as your arrives in your run? Because at the top you have you did 2 and 3 and 8 and 2, and you took 8 or 2 from 8. On the bottom one you did 0 and 9,
and so you're wondering, like, how do you know which number comes first in your subtraction? So that's an awesome question. So let's check out what happens if we reverse things and go the other direction. Yeah. So if we go the other direction and use the other point as our first values in our subtraction, we would have 3 minus 12 on top instead, and then we would have 2 minus 8 on the bottom. So 3 minus 12 gives us -9. 2 minus 8 gives us -6. The negatives cancel, and we get 2/3. So in the end, that's an excellent question. It does not matter. You can choose any 2 points on the line, and you can subtract either one first if you want, as long as you keep them straight. Right? Don't go subtracting your x value from your y value.
So
right?
3/2 is the same thing as a 2/3.
Oh, shoot. Thank you. I'm sorry. Sorry, that was 3/2. That was good. Yeah. Excuse me. 3/2. Yeah, so it doesn't matter. You can flop them around, whatever. You can use the origin like I did in this lower one. That made everything really easy.
Okay.
As long as the line goes through the point, you can definitely use it, right? And so for these two problems, for the first one, I chose those 2 points, but I easily could have just entered 4, 6, and 6, 9 if I wanted to. Those would have given me the exact same slope. Okay. So, just like we learned, the rate and or slope is always the vertical change divided by the corresponding horizontal change. In other words, rise over run. This is the same thing that they use in like the slope of your roof, right? They'll tell you the slope of your roof. They're talking about this type of slope, rise over run. So for basically all of our problems that we deal with in this class, that's always going to be change in y over change in x. Right? For miles per hour, we would be talking about change in distance over change in time. Vertical over horizontal. Right? If they asked us to give the rate, or the slope of a line to deal with this rate, 60 miles per hour in 3 hours, we simplify it, and we typically like 1 on the bottom for our rates. So here's the official formula for your slope. The official formula just says change in y over change in x, and this is the one to really remember right here. y2 minus y1 over x2 minus x1. That's really important. We're going to be using that a lot in this class. When we talk about slope, we typically label it m. And so when I say like, what's your m? Or if I talk about m up here, I'm talking about slope.
Is that like y multiplied by 2?
Ah, thank you for that. No, this is what's called a subscript. So that's like, you say y sub 2 or you say y2, but it's not y multiplied by 2. Basically it means, so if I wanted to find the slope between these 2 points, so if I said, oops, I don't want that. So if I said 1, 2, and 10, 24. Right, so if I said, well, show me the slope of this, I would want to label this first point x1 and y1, and this second point x2 and y2. Right, it's just a little index to sort of show which point you're working with. And when you do end up with these problems, it is really helpful to write down which one's x2 and y2. It makes everything much easier as you go along. So suppose I'm given a problem, and they ask me to find the slope of the line containing these 2 points. So to do that, I just use my slope formula, right? The slope formula is m equals y2 minus y1 over x2 minus x1. So I'm going to label my points real quick so I don't get confused. I'm going to call this x1, y1, and I'm going to call this x2, y2. All right, so my formula says plug in y2 minus y1 on the top. So I have y2, which is a negative 6, minus y1, which is a positive, which is a positive 3. On the bottom, I have x2, which is 2, minus x1. Now pay attention to what we're going to do here. Notice that x1 is a negative number, which means I have to put it in parentheses here. So I have 2 minus x1, which is a negative 4. On the top, I have negative 6. I'm subtracting 3 more. That leaves me with negative 9. And on the bottom, I have the double negative gives me a positive, so I end up with a positive 6. Okay, and this one ends up giving me a negative 3/2, not 2/3. All right, any questions on those so far? So just remember, if you're subtracting a negative number, just make sure you put it in parentheses like this and make sure it gets that double negative. Okay, as we just went over, it does not matter. It doesn't matter which point we choose as x1, y1, just as long as we keep them straight later on. Yeah, either point, right? If we would have reversed the x1 and y1 and x2 and y2 up here, we would have come up with the same exact answer. Okay, so let's talk about what graphs look like depending on their slopes for a couple minutes. So negative slopes, as you can see here on the left, they point up and to the left. Okay, so that is a negative slope over here on the left. It helps, especially at first, before you get the kind of feel of why slopes are negative, it helps to memorize this. So if you're dealing with a negative slope, just remember it's supposed to look like this. And a positive slope is kind of the opposite of that. It goes up and to the right. And it helps to remember, right, if we labeled this axis time, right, a negative slope goes down as time goes on. Right? A positive slope, if we labeled this time, goes up as time goes on, right? A zero slope, that's a horizontal line, right? Because a slope is rise over run, and this line has a 0 rise, the slope is 0. However, a vertical line, this is an undefined slope. Because rise over run, right? If run is 0, the whole thing is undefined because we can't divide by 0. Okay, we talk about steepness. Here is a positive slope, a slope of m equals 5, right? As you can see, this goes up pretty quickly. However, this is a slope of m equals 1/5. You can see this goes pretty gradually, right? And so as the slopes turn into fractions, it gets more and more gradual. The closer to 0 it gets, the closer to a flat line you're looking at. All right, once again, this is sort of the opposite of that. M equals -5, right? You can see that's fairly steep. M equals -1/5, that's fairly gradual. Okay, and actually, this is a good time to pull up the demo that I showed you guys last week. Cha-ching. So remember, this is kind of like our, this is our slope, the red our slope is in red, right? You can see as our slopes go into the negative high numbers, this gets very steep. As our slopes go closer to 0, it gets to be a more gradual line. And then we go in the positive direction. Okay? So that's slope. All right. Moving on. So, suppose we are asked to find the slope of a line given by y equals 4. We know that the y equals 4 line looks something like, I'm going to give this straight line a shot. That's not bad, actually. That's roughly the line y equals 4. To find the slope of this line, we use our slope formula, m equals y1 minus y2 minus y1 over x2 minus x1. If we consider any 2 points on this line, we'll just do this point and, I don't know, maybe this point. So the point on the y-axis is of the form 0, 4. And then this point over here, that's the point, what am I thinking? Yeah, sorry, 4. I had a little bit of a brain freeze there. Yeah, if you wouldn't have prodded me along, I would have paused forever. Just had that little spinny wheel on my forehead. Okay, thank you. So 4 is that point. So we can label this x1, y1, x2, y2, and y2 is 4 minus y1, which is 4, over x2, which is 4 minus 0. So you can see this just gives us 0 over 4, which is why this has a slope of 0.
So when we see that horizontal line on a paper, we have to go over it.
Only if you're asked to. If I ask you to find me the slope of this line, then yeah, you're gonna have to do this work. Yeah, unfortunately. But you know, on an exam, I don't ever ask you for this particular slope. Like, you know, I usually put this together with a few different things on an exam. So I might ask you to graph this line, but not to find this slope. This is more of just like, these examples are just so you can see why the slope is 0 and undefined in both of these cases. And so this one, x equals -3, this is a good illustration of why the slope is undefined on a vertical line. Okay, so we'll just take 2 points along this line, the point -3, 0, and then the point, we'll say -3, 1. Okay, so we'll call this x1, y1, x2, y2. And so I have my y2, which is 1, minus my y1, which is 0. And then, of course, on the bottom, I have my x2, -3, minus my x1. That's not what I wanted to write. Minus my x1. So you can see on top, I still have 1, but on the bottom, I end up with a -3 plus 3, which gives me 0, which is bad. No. Undefined. So that's why the slope of a vertical line is undefined. All right, so when it comes to concrete applications of this, the slope is also referred to as the grade. If any of you guys have ever worked a construction job, they talk about grade a lot. You know, the grade of the road is always the steepness of the road. So this particular problem is about skiing. So among the steepest skiable terrain in North America, the head wall on Mount Washington in New Hampshire drops 720 feet over a horizontal distance of 900 feet. Find the grade of the head wall. So remember, the grade is just the slope, and the slope is the rise over the run. So this is the rise, and this is the run. So I have a rise of 720. I have a run of 900. This is equal to something. This is equal to 0.8. Right, so the grade on this is 0.8. Okay. So that is the chapter on slope. In this chapter, finally, we're going to use the slope-intercept method of graphing. That's going to be your new best friend after this chapter. You're not going to want to brute force graph much anymore. That's kind of a pain. The slope-intercept method, you can look at a graph and graph it within really a couple of seconds. All right. So, just remember the slope of a line and the rate of an equation are roughly the same thing. Just like we went over in the last section, the slope of a line is the change in y over the change in x. I'll probably be repeating that a lot before this course is over. This is, once again, your formula. And it's calculated using these. Okay, so it's kind of repetitive from last chapter, but don't worry, it's building onto something. So once again, we are going to find the slope using these two sets, or using this set of points. Okay, the point 0, 4 and 8, 16. So, wants us to keep doing this. Okay, I might skip the next one. So, to find this, once again, I'm going to label these real quick. x1, y1, x2, y2. So my m is equal to y2, which is 16, minus y1, which is 4, over x2, which is 8, minus x1, which is 0. So 16 minus 4 gives me 12, 8 minus 0 gives me 8, and this in the end gives me 3/2. Oh, that's right. This was just to illustrate how we get the same slope from different points on the line. But since we sort of jumped ahead on that in the last chapter, we can skip it for this chapter. So just remember, you can do multiple points on the same line and you get the same slope. Okay. I'm sorry, this stuff seems to be out of order, maybe. Okay, so anyway, basically, so now that we know how to find a slope, right, we know that this slope tells us that we have a rise of 1 and a run of 4 for any particular ratio on a line. That means that we can, if we have 1 point on a line, we can count up to the next point using this slope. Let me show you how that's done. So if we have a y-intercept, the point 0, 2, we can plot that point. So I have 0 on the x-axis and up to 2 on the y-axis, which gives me this guy right here. And then I can mark out a 1/4 slope to my next point. And what I mean by that is rise over run, right? This is equal to a rise in 1 for every run of 4. So the way I find my next point is to rise 1 and then go over 4. Okay, so I go up to 3, and then I go over 1, 2, 3, 4 to this point. So that's my next point on this graph. All right, so I rose 1 unit right here in blue, and then I ran 4 units right here in yellow. Okay, another way that I could have found this point was to go in the other direction. Okay, and so instead of rising 1 and running 4, I could have dropped 1 to the 1 point and then ran in the negative direction 4. So 1, 2, 3, 4. Here's another point on that same exact line. Okay, so that's really all I need to graph a line is a y-intercept or any point, and then the slope, right? To graph it, or to finish this guy off, I just draw my straight line and try to get it to intersect with these. We'll say that's probably close enough there. Okay. All right, so any questions on that one? I know, it's a little bit weird. We're going to keep trying this. So here's another example. So in this one, they ask us to draw a line that has a slope of -1/2 with a y-intercept of 0, -3. All right, so to graph this line, first I graph the point that they're talking about. So I have 0, -3. So I go 0 in the x direction and down to -3 in the y direction. And then this says I have a -1/2 slope. Okay, so so when we do negative slopes, you can do it two ways. You can either just memorize which direction a negative slope is supposed to go, or you can realize that we're actually talking about fractions when we're drawing out these negative slopes. And so a -1/2 slope is equal to a -1 over +2. It's also equal to a +1 over -2. So when I count off a negative slope, I can go up in the positive direction to 2, and then I can go over 2 in the negative direction, 1, 2. So I counted up 1 and over 2 in the negative direction, and here's my new point. And so this one, like this jump right here, this represented the sort of, this was +1 and -2 direction over here. Or I could go in the downward direction, right? And so I could go in a positive or a negative rise, which would take me down 1, and then a positive run, which would take me over 2 to this point here. And so this one represents sort of the fraction that has a -1 run, so it's negative in the top and positive in the bottom. If none of that makes sense, don't worry about it. This is something that is tough to figure out, especially at the beginning. If none of that makes sense, just memorize which direction the negative should go in, and just count off 1 rise and 2 run. Did you have a question? I'm sorry. Okay. So, let me erase all this chicken scratch stuff. So finally, I would draw my line through these 3 points. Cha-ching, perfect line.
Is that kind of line acceptable?
Absolutely, it actually is.
Okay. So I'm digging for rulers and books.
Yeah, it's okay. I understand the graphs are definitely not perfect. Okay, so we have a slope of 2, m equals 2, and a y-intercept of 0, 1. All right. So, once again, we have a point and we have a slope, and that's all we need to graph. So we graph the point, which is 0, 1, which goes right there, 0, 1. I'm going to label that since it's my y-intercept, and then I have a slope of 2. Remember that 2 is equal to 2, oh, oops, that's not a 2. I'm off today. 2 over 1. So I have a rise of 2 and a run of 1. All right, so I go up 2, 1, 2, and then I run 1, and I put my next point here. Or I could go in the double negative direction. I could go down 2, and then -1 run to give me a point here. And I draw my line. Okay, and so the equation of this particular line is this. Y equals 2x plus 1. What we're about to see is that when an equation is in this form, this is exactly where the slope ends up, and this is exactly where the y-intercept ends up. So we're going to learn that in just a minute. So whenever you see something in this form, you'll be able to graph it exactly how we're graphing these. And here it is. So the official name of this is the slope-intercept equation, right? And this is it right here. In its general form, it is y equals mx plus b. When we have something in the form y equals mx plus b, the slope is always the coefficient on the variable, okay? So the slope is m in this form. The y-intercept is always the point 0b. So if we're given an equation in this form, we have all the information we need to graph it without even calculating anything. We just plot the y-intercept, and then we count off the slope from that. Once you get used to this form of graphing, it's really easy, really, really easy. But you got to get used to it first. It can have a little bit of a learning curve at first. So I would definitely, as you're graphing, I would keep this equation near, or just memorize it, so that you know what form you have to be in. And what's significant about this form, kind of, how do you know you're in y equals mx plus b form? You've solved for y. That's how you put it into y-intercept form, is you solve everything for y. Okay. So, suppose I'm asked to find the slope and the y-intercept of each of these equations. What is the slope of part A? Y equals m times x plus b. So m is my slope, right? M is the coefficient of the variable. This is my coefficient of the variable, right? The number attached to the variable. So right here I can say m equals 4/5. Now they want the y-intercept. Remember, the y-intercept of any y equals mx plus b is the point 0, comma b. So in this new equation, my b is equal to -8. And so my y-intercept, y-int, is equal to the point 0, comma -8. So right there, I've picked out the two pieces of information that I need to graph any equation. Right? And so without really calculating anything, I can go ahead and graph this equation if I wanted to. I don't. So on part B, they ask me again, what is the slope and the y-intercept? Well, we have to be careful because this is not in the form that we need it to be in. Right? The form that we need it to be in is solved for y. So we need to basically get the y alone to put this in y equals, to put this into slope-intercept form. So to do that, I'm going to subtract this 2x from both sides. Right? So I am going to, let's see now, so -2x minus 2x. These guys over here go away, and I end up with y equals minus 2x plus 5. So when I'm dealing with graphing, I like to write the variable term first, even if it's a negative. Right? Your mind might be saying, well, this looks more natural to me, but since the form has the variable coming first, I like to put the variable first when I'm graphing it, just so that it looks the same. Okay, so now that I put it in y equals mx plus b form, what's my m equal to? Good, -2. And so if we were looking at a slope of this, or if we were looking at a graph of this, right, the graph would do something, whoops, wouldn't be exactly this, but, okay, let's hope the graph wouldn't do that. Go away. Maybe the voice command worked. Okay, so the graph would look something like that because it's got a negative slope, right? All right, so what's the y-intercept?
0, 5.
Yes, perfecto. Y-int equals 0, 5. Okay, on part C, we do the same thing. Right? We're asked about the intercept and the slope, so I have to put this into slope-intercept form first. Okay, to do that, I'm going to go ahead and subtract 4x from both sides, so minus 4x minus 4x. Those will cancel. I'll have -4y equals -4x plus 7. And remember, I need my y to be isolated so that -4 can't be out there. So I'm going to have to divide everything by -4. So pay attention to how I do this. It's easier just to do these separately instead of dividing the whole thing by -4. So instead of dividing the whole right side by -4, I just divide each term individually by -4. Okay, so these ones will cancel, and I end up with y equals, I have -4x over -4, so my -4's will cancel again. And then I have 7 over -4, which is -7/4. Okay, so what's my m on this example? Not quite. Remember, it's y, careful, it's y equals mx plus b, right? So m is the coefficient on the variable. So what's my coefficient right here? 1. Good. Yeah, there's a little 1 out there. Be careful. Okay, so m equals 1. And then my y int is equal to the point 0, comma, -7/4. Yeah, absolutely. Yeah, that's totally fine. Okay, so now what if we're asked to do this in the opposite direction? They give us a slope here. Whoops, that's supposed to be a highlighter. They give us a slope here, and they give us a y-intercept, and they ask us to create an equation. So my standard equation in slope-intercept form looks like this. So all I need to do is fill things in. So my equation with these two things, my m gets replaced by this fraction, -12 over 5x. And then my b is the second number in my y-intercept, so plus 11. And there's my equation. Okay. So here we're given a graph, and we're asked to determine an equation for this graph. So before I do anything, I'm going to go ahead and write out my standard equation formula, right? My equation should look like y equals m times x plus b. All I need to do is figure out what m and what b are, and I can create this equation. Okay, so m, of course, is the slope, and b is the y-intercept. So first, it might be easier to find the point b. So my y-intercept is where I intersect with the y-axis. Right here, it says that my y-intercept occurs at the point 0, 2. So I have y-int equals 0, 2. So I have one piece of information I need. Now I just need the slope to go ahead and fill this completely out. So the slope, m equals y2 minus y1 over x2 minus x1. All we need is 2 points to fill this out with. So this first point here, my y-int, that's definitely a point, so I'm going to label this x1, y1, and I'll use this other point way out here in the distance for my second coordinate. So this one is at the point 7, 6. All right, so I have 7 on the x, 6 on the y. So this is x2, comma y2. Okay. Now that I have those 2 points, I'm just going to plug them in here. So this is equal to y2, which is 6, minus y1, which was 2, over x2, which was 7, minus x1, which was 0. Okay, 6 minus 2 is 4, and 7 minus 0 is 7. So now I have my m and I have my b. All I got to do is plug them in. Y equals mx. If m is equal to 4 sevenths, then I have 4 sevenths times x. And if b is the second coordinate in my y-intercept, then b is just equal to 2 plus 2. There we go. This is an equation for the graph that we've just been shown. Okay, So when they ask you to determine an equation or fill out an equation, the first step I like to do is write down the general form of the equation that you're going to fill out, right? From that, you can see all the information that you're missing, right? If I write this guy out, I can see that all I need to make this a complete equation is to fill out M and B, and I'm done. All right. Moving on. The final step. So now we're actually going to graph straight from the equation, right? This is so similar to what we have done before. The only thing is we're picking pieces of information out of the equation. So we're given this equation. It is in y equals mx plus b form. So that makes things easy for us. So we have m equals 3/4, and we have the y int equals the point 0, 5. Okay, so to graph this, I go up to the point 0.05, make my mark, and I label it. And then I need to mark off a 3/4 slope. That's really inconvenient for the way that I've numbered this graph, as always. Right? Okay, so we are going to just draw some extra points in here. So we have 5, 6, 7, 8. I guess it would help if I erased my labeling of the point right here. Okay. 6, 7, 8. Okay, so to do to go in the positive direction and find a new point, I have a 3 rise and a 4 run. So I rise 3, 1, 2, 3, up to 8, and then I need to run 4. So I have 1, 2, 3, 4. Okay, so there's my new point, and put my label down here. All right, and so to find the other point, sort of on the opposite side, I can go in the negative direction for both my rise and my run, which results in an overall positive. So I go -3 rise, 1, 2, 3, and then I go -4 run, 1, 2, 3, 4, to right about there. Okay, and when I do these, I sort of do that both direction thing sort of just to illustrate that it can be done. On your homework, you don't need to do that. If you just find one point, it's totally fine. You don't need to go in both directions. Okay, so that's how you graph if you have a slope-intercept form. Right? That's a lot easier than brute force. Okay, so this one, we're asked to graph this one as well. Well, before we graph it, it's not really in a convenient format, so we're going to have to deal with that. So I got to solve for y first, and then I can graph using this simplified method. So I need to get my y alone, which means I'm going to have to subtract 2x from both sides. So minus 2x minus 2x. These guys will cancel. I end up with 3y equals a -2x plus 3. Now I divide every term by 3. These guys cancel. And I end up with y equals a -2/3 x plus 1. Okay, so now I'm in the form that I'm used to graphing in. I can tell from here that my m is going to equal -2/3, and that my y int is going to equal 0, 1. All right, so just like always, I plot my y-intercept, and then I count off my slope from there to complete the graph. So my y-intercept is at the point 0, 1, which is right here. Now I need to count off a -2/3 slope. So that has a run of 2, sorry, a rise of 2 and a run of 3. So I rise 1, 2, and I go 3 in the negative direction. 1, 2, 3. Or If I wanted to go in the other direction, I could always drop 2. 1, 2, and then go 3 in the positive direction. 1, 2, 3. You only have to do one of those, though. All right, any questions so far? No? Okay. Here is, this is in your chapter. If you want sort of, if you're confused by the thing that I'm doing going in both directions, go ahead and sort of review this. Of course, I didn't write down the page number. 206, thank you. 206. If you want to kind of review that and see why I'm able to go in both directions, you can review that. Okay. So, onward. Slope and parallel lines. So, the definition of parallel lines is this. 2 different lines are parallel if they have the same slope or if both lines are vertical. If they are horizontal, then they will both have the same slope. Right? They have to mention that if they are vertical, because a vertical slope is undefined, which means you cannot have the same slope as that because it's not even a number. Right? But horizontal has a definition, yeah. So that falls under the first part. That's good to pay attention to these. Okay, so so basically, what that means in algebraic terms is that we need 2 conditions satisfied for parallel lines. They have to have the same slope. That's one condition. And the second condition is they must have different y-intercepts. Right? The reason why they have to have different y-intercepts is because the definition specifies that the lines must be different. If a line has the same slope and the same y-intercept, it's just the same line, right? And so the lines have to be different. So these are the 2 conditions to be parallel. If you're asked why a line is parallel, these are the 2 reasons that you give. So in this example, I'm asked to determine whether the graphs of these 2 lines are parallel. So in this first equation, I can pick out the things I need right off the bat. So I have my m is equal to -3 here, and my y-int is equal to the point 0, 4. I'm not sure what those are for this particular equation, though, so I'm going to go ahead and put it in the y-intercept format. So if I subtract 6x from both sides, minus 6x minus 6x, I end up with 2y equals -6x minus 10. And now if I divide everything by 2, these guys will cancel, and I end up with y equals a -3x minus 5. Okay, so now we can pick out the slope, intercept, and the slope, and we can see if these 2 lines are parallel. So on this right-hand side, my slope, m, is equal to -3, right? So that condition is satisfied, yes. And my y-int is the point 0, -5. So we notice that those are different. So yeah, we can say these are parallel. And if you're not sure how to show your work on those, it'll suffice if you just, show me that you know what the slope is, and you say the slopes are the same, y-intercepts are different. Chances are you'll have plenty of work to show on this. Okay. Now suppose we're looking at this one. And actually, maybe, no, we'll just do it. Okay, so they want to know if this is parallel as well. So once again, it's the same graph with this. So m equals -3, and our y-int is equal to the point 0, 4. All right, and once again, we have to play the same game with this guy on the right to make sure that these, in fact, conform to the parallel rules. So I'm going to subtract 6x from both sides of this equation so that I can isolate the y. So minus 6x minus 6x. Now I have 2y equals negative 6x plus 8. If I divide everything by 2, I end up with y equals negative 3x plus 4. And right off the bat, I can see this isn't going to work because they're the same exact line. Right? When it's the same line, they're not parallel. They need to be different lines to be parallel. But I can see the slopes match, so I satisfy condition 1, but the y-intercepts are the same, which means I don't satisfy condition 2, so they're not parallel. Okay. So, oops, that's supposed to, sorry, I was supposed to have a little thing up. There it is. Okay, let's play a little game. So yeah, which one of these options is this particular graph? I'm sorry if that's tough to see. I can't zoom in. Oh wait, maybe I can. A little bit. Maybe not. Okay, so what do you guys think? Which of these options over here is this particular graph? Well, let's see. We intersect at the point 0, 1, right? Which means that the constant term has to be a positive 1. So our options are this one, or this one, right? What's our slope? Yeah, it is 4, right? Because we start here and we do a 1, 2, 3, 4 rise, and then a 1 run, so a slope of 4. Boom, it's this one. Right? So here. What about this one? What's this one? Well, so exactly, yeah, we've got a negative 3 intercept. So the constant term has to be a negative 3. So it's got to be one of these 3 options on the bottom here. I think you're correct. Wait. Careful though. So what do we do here? So we go up 1, 2, and we run 1. So it's a slope of 2. Not just 2. Negative 2, right? Yeah. That guy right there. Boom. What about this one? 4 is the constant term. We know that right off the bat. Okay, so how do we, let's count off this slope. What's this slope right here? What do you guys think? 2x plus 4. Yeah. Yeah, it's got a slope of 2, right? Because this goes negative 1, 2 run, or sorry, negative 1, 2 rise, and a 1 run. So it's 2 over 1. So 2x plus 4. That one. What about this one?
Negative 2x, positive 2x. 2.
Good. Right, yeah, you can see that right off the bat. It crosses at negative 2. So it's got to be one of these with the negative 2's here. It's in a positive direction. We rise 1, 2. We run 1 before we land on an intersection. So yeah, it's a positive 2 slope with a negative 2 intersect. Boom, that guy right there. You guys tired of this? You're lucky. It was the first time I rolled this out. I actually made students come up and try and play it in front of the class, and it was terrible. It was the worst day ever. People got up here and they're like, I don't know what to do, I quit. It's like, all right, I won't make you do this. I promise I won't ever make you do this again. So anyway, that's that. If you guys want to practice this sometime, I know it's kind of goofy and it's a little simplistic, but it'll really like kind of drill this into your mind. If you want to practice this sometime, you can come up to my office and I'll just let you have this computer for a while and you can mess around with these graphing games. So that being said, that is the end of class today. Thank you very much for your patience. And I won't be in the Student Center.